The effectiveness of TCP as the transport layer protocol is beyond doubt. When it is used in conjunction with various application layer protocols, it becomes important to understand when the application layer protocol must invoke TCP handshaking for connection establishment and termination. Therefore, the topic of connection management at the transport layer becomes extremely important. In this module, we shall look at how TCP connection is managed vis-a-vis an example protocol HTTP 1.1, that is persistent HTTP. Then we'll see when connection management takes place either in connection opening or connection termination, what is the process or the number of phases through which TCP transitions. And then we'll understand if the impact of connection establishment and termination is so profound, how can we keep it optimal? And that will lead us to the modeling of the TCP connection management. The research paper that I refer here is by Edith Cohen, Managing TCP Connections under Persistent HTTP, and the view graphs and some of the figures have also been adopted from Kuros and Ross in their famous book titled Computer Networking, Top-Down Approach Featuring the Internet. So when HTTP invokes TCP at the transport layer, the service at the application layer invokes TCP, and upon receiving an HTTP request, say R, the server decides on a holding time interval TR. This holding time interval is the duration in which TCP is going to remain persistently active. The server then leaves the connection open for at most TR seconds for the moment it receives R. It would be lucky if within the same time interval, more HTTP requests are sent and more responses are made because the connection has already been established. But if there is no activity at the HTTP layer, the purpose of keeping TCP connection opened is lost. So if a new connection, R complement, arrives within the time interval TR, then a new holding time, TR complement, is activated. Otherwise, the connection is terminated after TR expires. The overall state transition diagram for TCP is shown in here. Here we see that to transition into different states, TCP client and TCP server go through various stages, and each stage necessitates the transmission and reception of connection control messages. This is how TCP client behaves when from the closed state it enters into the established state, first going through the half open, then full open, and then half close and full close. It is the TCP server lifecycle. Again, the total number of messages that it takes to take TCP through different transition states is also mentioned in here. Now, if connection management has to be done, certain policies or certain rules must be defined. In this paper that has just been referenced, there is an example given for, say, a policy A, which would be an algorithm to manage TCP connection. It is going to determine the interval TR for every incoming request R for which the TCP remains connected and HTTP becomes persistent. Now let's assume that there is a sequence of requests back to back as S. Now, since it's a random process, the number of requests arriving could be on different sockets or on the same socket. If the requests being made on the client computer are on the same socket, then TR shall be refreshed with the arrival of every new request. Otherwise, it is going to be terminated after TR. Now, when the connection has been established and it is being managed using that policy A, we have to now assess if our implementation of this time period TR is good or otherwise. So, the authors of the paper have introduced the concept of profit. Profit refers to the number of hits. That is, the profit of a policy on a sequence of incoming requests is the number of requests that did not require opening a new socket. Likewise, there could be introduced a notion of loss. That is the number of misses, MA, of policy A on a sequence of incoming requests S, as the number of requests arriving that require a new socket to be opened. The cost of opening the socket, HA, of a policy is the total time measured in seconds for which the TCP connection remains opened. If we analyze the profit-loss model vis-a-vis the time for which the TCP connection is kept open, we can think about modeling the performance of TCP connection management by looking at it as a trade-off between the open cost measured in seconds and the number of hits or the number of misses.